Welcome everyone. We are going to see a video lecture on computer networks. Topic is subnetting in IP version 4. Presented by myself, Uday Kumar, Assistant Professor, Department of Computer Science and Engineering, Hindustan Institute of Technology, Coimbatore. Before entering into subnetting topic, after learning or the objectives of subnetting is to understand about the transmission of information or the data from one network to other network. It comes under understanding level. Objective 2 will be able to divide big networks into a subnetworks. This comes under knowledge level on apply level. Objective 3 to avoid the wastages of IPs. This comes under apply level. After learning this subnetting, what will be the outcomes? Course outcome 1 will be able to learn how a large network is divided into subnetworks will be identified, and the students can able to learn this one. Course outcome 2 will be knowledge about the subnet or the network. So, what is subnetting? A subnetting is nothing but it is divided a large network, a large organization network into a subnetwork. So, mainly a subnet is calculated with the help of the IP address. So, look into the diagram. So, a large network is dividing into a subnet 1, 2, 3 and 4 or much more. So dividing this a large network into a multiple networks is called as a multiple subnetworks. So important points to remember is always a network is divided into equal halves called as subnetting. To avoid the wastages of IPs, we are going for the subnetting. So there will be two types of subnetting. One will be a fixed length subnetting or a classful subnetting. The second one will be a variable length subnetting or a classless subnetting. So after learning the topic fixed length subnetting, you may have some idea that all these fixed length subnetting will be having a equal divides, equal sharing of parts. Whatever is given to the subnet 1, the same thing will be given to all other 3 subnets. So what will be given is the subnets will be of the same size, then number of hosts given will be also the same thing. All the 4 subnets will be having the same subnet mask. So you may see here this is a circle or the pizza. So a full sized pizza is divided into a equal halves sizes, subnet 1, 2, 3 and 4. So the second one will be a variable length subnetting. So previous is fixed length, now this variable length. So a variable length is nothing but whatever the values are given, that values will be divided into an unequal halves. So you may see subnet 1 is different size, subnet 2 is different size, subnet 3 is different size and subnet 4 is different size. So whatever is given on the all the 4 subnets is of one unequal sizes. So before entering into subnetting problems, so we need to know a CIDR. So what is CIDR? It is a classless inter-domain routing. So classless inter-domain routing is a main topic which helps the data packets to transmit from one source to another destination based on the subnetworks. So for this purpose we will be having a CIDR value. So how these CIDR values are calculated? So these values are calculated based on the subnet masks provided with the IP classes or IP addresses. So everyone knows there is a 5 different classes of IPs. So class A, B, C, D, E. So class A starts from 0 to 126. Class B IP starts from 128 to 191. Class C IP starts from 192 to 223. And class D starts from 224 to 255. So this tabular column will says the what is classful mask, CIDR value or mask, the number of host for IP address, all 5. So the first IP address is class A. It starts from 1 to 126. So here the classful mask or the subnet mask will be 255. So how the CIDR mask is calculated? For first class A, it is /8. How it is /8? So the first mask, classful mask for class A is 255. So how this 255 is calculated? So based on the formula 2 power n, we need to substitute value starting from 2 power 1. So 2 power 1 will be 2 power 0. So 2 power 0 is 1. So 1 it will be 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 like that till 2 power 7. So 2 power 7 will be 128, 64, 32, 16, 8, 4, 2, 1. So it is totally 0 to 7. So total of 8, totally 8 values will be there. So if you add all the 8 values, so 128 plus 64 plus 32 plus 16 plus 8 plus 2, 8 plus 4 plus 2 plus 1, you will get 255. So totally 8 values. So 8 ones. If it is 8 ones, it is called as 8. So /8. Likewise for class B, 2 times 8 will be there. So it is /16. For class C, 3 times it will be 255, 255, 255. So 8 plus 8 plus 8, 24. And for class D, it is 4 times 8. So 4 into 8, 32. So totally 4, if it is 4 8s, I mean 4 outlets are on, it will be 32. So next will be a host. How many hosts can able to connect with a single IP? So the first class A will be, it is 16.7 million devices. So how these devices, devices are also called as host. So how this 16.7 million is calculated? So you may see in classful mask, so there is 255.0.0.0. So 3 zeros, you'll be having 3 zeros. So the total number of devices can be connected as 0 to 255, it is 256 devices. So multiply out 3 times 256, 256 into 256 into 256. So you will be having 16.7 million hosts. The same for class B, it is 2 zeros, so 255. So 256 into 256, you will be getting 65,536. For class C, it is 256. Then for class D, it is not available because all the values are there. So 255, 4 times 255, so it is not available. So for this you need to know. So 255 will be called as network IP address, sorry, network address, and balance zeros, 3 zeros or 2 zeros or 1 zero, it is called as host address. So later on I will be discussing it. So last one, class C, will be reserved for research purposes. So here you may see the example. So it is this is some sample example. So for first thing A, comma B, comma C, comma D /X. So X represents the number of bits starting from the left hand side. It is sometimes /x is also called as a CIDR value. Later we will be discussing in the example. So here it is a combination of zeros and ones. So 4 octets are available for the IP address. So I am divided into A, B, C, D. So here the X indicates the values, the values of bits from the left. So whatever the values are present on the left hand side, it is called as the host bits. Then the balance bits are called as the network bits. So here example. So example will be a class A. So it's a sample example. Class A. So class A's subnet mask will be 255.0.0.0. So that means 255 means 8 times 1 will be given here. It is on. So the balance will be zeros. So the whatever the values, the 1 is there, it is called as your network address, and the balance zeros, 3 times zeros, are called as a host address. So here I have given for all the 4 IP addresses. So first class A, it is 255.0.0.0. So 8 ones will be there, the balance will be zeros. So subnet mask will be 8 bits. So for class B, 2 times 255 will be there. So 16 bits will be 1. The other balance 16 will be 0. So subnet mask will be 8.8. So 16 bits. For class C, 3 times 255, 255, 255.0. So 3 times, so 8 will be there. 8 plus 8 plus 8. Okay. So subnet mask will be 8.8.8.0. For class D, all the 4 octets will be 255. So all the values will be 1. So subnet mask in bits will be 8.8.8.8. So this is a subnet mask for the class A to class D. So now we'll be moving to an example problem. So I have taken a class B IP address. It is 172.16.0.0/16. So here 172.16 will be your network address. Then the balance 2 zeros will be called as host address. So here /16 is given. So the subnet mask will be 255.255 because 2 times it will be 8. So 8 plus 8, it will be 16. Here before entering into it, we need to represent the /16, which will be converted into a binary values. So to convert the binary values, we need to know the subnet mask of a class B address. So it will be 255.255.0.0. So 2 times 255, that 255 will be converted into zeros and ones. So 8.8. So 2 times 8 will be that. Then balance will be zeros. 0.0. 8 times 0. Then another 8 times 0. So I have mentioned the last point. So the first 16 bits will be allocated as a subnet mask for network address, and last 16 bits will be for a host address. So now we are entering into a problem. So to find the given IP address, we need to have a 4 subnets with the help of the same IP address. We need to allocate the IP address for these 4 different departments or 4 different subnets. So 4 subnet 1, 2, 3, 4. So for that we will be having 3 topics, 3 important topics. So first will be your subnet, second will be a host, third will be a subnet mask. So how to find the subnet? So there will be a formula 2 power n. So if you substitute 1, 2 for the value for the n, 1, 2, 3, 4, 5, 6, 7, 8, like that, if you mention, you will get the subnet mask till up to the number of hosts able to connect in class B. So there will be totally 65,536 devices can be able to connect. So it will be in the forward direction. So starting from 1 to till 65,536. The second one will be host. It will be starting from 65,536 in a reverse order till the 1. Then the last one will be subnet mask. So subnet mask will start from the whatever the values given in the question. So it will be /16, starts from 16, 17, 18, 19. So now we need to calculate the number of hosts is able to connect. So how to identify the number of hosts? So we are given a 4 subnets. We need an IP address for the 4 subnets. So in the tabular column we have already solved. So in the fourth subnet the number of hosts can be able to connect is 16,384. The subnet mask given is /16. So 16,000 devices cannot be connected. So that can be the next slide. So before that we need to find the subnet mask for the given IP address. So before subnet 4 we will be having two subnets. So have a about it by selecting two subnets 1 and 2 based on the table given. So if you select that 1 and 2, that will become an another that will be given in the another table. So 128 plus 64 plus 32. So that 2 will become 128 and 64 because we have a formula 2 power n because each octets in IP address has 8 bits. So 2 power 0 till 2 power 7. So it will be 128 and 64. So that will become 1 on. Okay, then add that to address 128 plus 64. It will be given new host address. So it will be this new subnet mask will be 255.255.192.0. So after finding this new subnet mask, we will be going to find the new host address. That means a network ID and the broadcast ID. So here first we need to find the network ID and the broadcast ID. These two IDs are reserved IDs which cannot be changed. So the first network ID given is 172.16.0.0. Then the host range is 16,382. Previously we have given 16,384. But what has happened is two IP addresses are being reserved. So one is for network IP and the other will be for broadcast IP. So the IP starts from 172.16.0.1 till 172.16.63.254. Why? Because the previously I said so totally we will be able to connect only 256 devices, but we have got 16,384 devices cannot be able to connect it. So that 16,384 devices divided by total number of devices 256. So if we solve, we will be getting 64 devices. So that 64 devices will be your broadcast time. I mean a 64 devices. So your IP, the first subnet mask subnet will be starting from the given IP address 172.16.0.0 goes up to 172.16.63.253 because first IP is reserved, the last IP is reserved. So you will be able to provide the IPs in between because it is first IP and the last IP is reserved. So two IPs have been already reserved. So that's why I mentioned as 16,382. Two IPs is reserved. So the second will be starts from 16.64 because we will be adding in another 64 to the previous value. So 63 plus 64, 127 or 128. So 172.16.64.0 till 172.16.128.258. So it goes on by adding another 63 to the another network. So we'll be getting the answer till 172.16.255.255. So this is a way we will be able to calculate the IP address. So subnetting is works on with the help of this method. So based on this topic we have given a created a quiz, attend the quiz. So any question? Thank you.